Okay, so I think we are ready to start. Thank you everybody for coming. Uh, Today we're going to be doing a small workshop on ChatGPT and Blender for CAD. And I'm joined by Esan, who is a student at New York University, who is also going to be helping us out later with some of the exercises. So uh, I hope you can hear me well. If anybody has any issues, just let me know. And basically, I'm Jorge Montalvo. I'm from Colombia, and I'm the manager for the Advanced Manufacturing Workshop in New York University, Abu Dhabi, which is basically a fab lab that serves from undergraduate to postdocs, going through a range of different applications. And it's also open for the community, and we do a lot of workshops with schools and uh, colleges all around. So it's a very uh, accessible and nice place to learn. And in one of the classes I teach, which is computer-aided design, we started working with ChatGPT to test the capabilities. And from there, we saw that it's actually a very nice tool to explore when you're starting to work with CAD. And that's why we decided to host this workshop. So Blender, as I said at the beginning, is an open source software that you can download to most operating systems. So if you don't have it, please install it if you want to follow along. And once you install it, we're also going to be using ChatGPT. So probably most of you use it already for many applications, but if you don't, just go to OpenAI and create your account so that we can start making prompts and making questions through ChatGPT. Okay, so we'll go to Blender, which is this is the main interface once you have it installed and it's ready. So basically, a few years or months ago, there were some plugins that you could actually run through Blender to use ChatGPT to generate the scripts for you. But now these are all paid or have some limitations with the free version of ChatGPT. So the basic workflow that we're going to be using is basically copying the scripts that we generate to the scripting tab. So once you're in Blender, if you come to scripting, you can create a new script. And then once we paste the code here, it'll generate whatever we need in the space, in the modeling space. So normally we can redistribute the screen and have it as you need in order to work. Okay, so let me go back to the presentation. So in scripting, you create a new script, and then we can go to ChatGPT and generate a very random code. So let's try it out. Let's do our first model. So if we ask ChatGPT to generate a 3D model, we need to specify to do it through a Python script, okay? So normally you can ask ChatGPT to create a script and then describe whatever you need to generate, okay? So just to start, let's generate our simple cube. So we can ask, can you write a script for Blender using Python to create two cubes. So let's have it like this, very generic. And if you see, it will create the script for you. Even it will explain the process it's thinking to generate it. And if you copy the code, then you can easily go to Blender, and in scripting, you paste it. And if you click on play, you'll be ready to create the two cubes. So you can see that by default, normally there's already a cube. So if you don't want it, you can always delete it. And so actually I'm gonna delete everything so that we have a clear space. And if I run it again, you can see that it creates the two cubes for us, okay? So let's try it out. Let's please feel free to chip in and participate as much as you want. And if you're having any issues, let me know and I'll try to help you. So just let's make sure that we can create simple cubes to start, and then we will go into more fun exercises. Any issues or everybody is good?
Can we ask it to give if we gave it dimensions of our cube
Yeah,
or shape, will it then generate the code with the dimensions?
exactly. So that's actually part of what we were planning to show you next. Depending on how specific or how generic your prompt is, the results you get are gonna be more accurate or less accurate. So if you, for example, specify the dimensions or the location inside the space, it will try to create it as much as accurate as possible. So the more we try and the more you give them specific commands, you will see better results. So for example, I just asked it to create two cubes and it assumed its position, it assumed its sizes, and it assumed a lot of things. But as you start giving more specific instructions, you will get much better results. So actually, it's very interesting because if you try this in your classroom, every time everybody will get a different result if you're not very specific. So for some, you can get the two cubes like this, one stacked on top of the others. Or if you ask it to be stacked, then it's going to be one on top and one besides. But okay, so I have a question here about how to clear the script. So normally the easiest way is just to create a new one. So if you go back to Blender, you can always create a new one. It'll give you a blank space, and then you can paste again and play, and then it'll run the new one. Okay. And if you see right now, it's working, but one of the cubes is the initial one. So for example, if I don't want that, I could go back to ChatGPT and you can see, can you create a Python script that clears the space and then creates two spheres, for example. So now if I ask it to do that, at the beginning it will delete the cube or any things that you have on the space, and then it will create whatever you need. So I just come here, create a new one, paste it, and run it. And now you can see that it changed, it deleted everything that we had in the space, and now I have two spheres in my volume. Okay, so uh, let's go back to the presentation. And let's try something a little bit more random. So for example, you can ask it to create more than one element. So for example, here I was asking ChatGPT to create 20 random spheres, but that now I'm specifying where to create it. So you can say within an area or in a specific coordinates, and then you can see uh, what it creates. And you can also limit, for example, the sizes of the sphere. So you can always tell them to create spheres with random sizes from different intervals. So you can say, for example, from 1 to 4 millimeters or any units that you want to use, and to place them in any position that you want. Okay. If you don't see the scripting in the Blender, you can always go Alt T and it will bring you to the scripting. And normally, if you click on the plus, you can see more tabs because sometimes they can be hidden. So you can always look for it, but for sure it's there. Or even in this menu here, you can always, if you click in these two elements here, it's also text editor F11, and there you can also paste the script and it's gonna work. Okay, so were you successful trying to create more than one element? So now let's try something a little more random, but I'm gonna ask a few of you to share your screen or send us the pictures in the chat so that we can see the different results. Uh, for example, here, I asked Python to create a Mayan pyramid, okay, using 1 millimeter blocks, and I specified the number of blocks I want in the base, okay? But let's try it out, and you're gonna see that everybody will start getting different results or different interpretations, and even depending on how you uh, specify the pyramid. So for example, here I'm being a little specific. I'm saying how many sizes and what type of blocks and the size of the base, but it's gonna start being very random if you just ask it, for example, to create a pyramid or to create an object. So this is what I got, but please try it out and send the images and I can show them around. Uh, or you can also share your screen if you want so that we can see how it changes from one iteration to the other. You can also play or ask the Blender the ChatGPT to create things with different colors or different textures. So you could ask it to for the cubes to be random colors or to create different materials, and it will also work. Okay, so this was, for example, what I got when I tried it before, but let's see what happens if I try it now. Script to model pyramid. I'm gonna have it very generic, and let's see what it does this time. If I go to Blender, I'll create a new. So you see, if you have a very generic code, sometimes it will not. So for example, right now, this is not even close to a pyramid. Was anybody successful in trying to create one? So if it didn't work, what you can start trying is to change your prompt and be a little bit more specific. So for example, if I go back to my presentation, let me copy this same prompt, and let's see if this time that will be more accurate. So when you start specifying what elements to use and the size and the position, your chances of success are gonna be a little bit higher, but let's try it out. New. And something you can always try is you can always iterate within ChatGPT. So you can always tell it, this code is not working, and you try again. And it will try to do it in a different way. But this is gonna be, so once you try this in a classroom, it's always gonna be like 50-50. Sometimes it will work for some students perfectly, like this example I have here, but then for others, it's not gonna work, or you're gonna have some issues because it's just generative AI, so it's random. And let me delete everything. So this one is still not working. Okay, but I think I have the code here. Okay. So Jose was able to do it. You can see his result here. And he has a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 level pyramid, which was interesting. Uh, but the chances of success will increase depending on the prompt that we use. So just as some suggestions, you can always try to be more specific. So if you specify the size, the position, the type of shapes, the environment or the lighting, if you want to even animate, the colors, and even the limit, so you can confine it to a certain space, then you'll have much better results. So you can start seeing in the chat the different results that everybody's getting. And depending on what you specify, you can get very different. So for example, here we get just like a triangle, but it's interpretation of a pyramid. But when you use this as a tool in class to actually and make students understand the importance of the prompt and how to create uh, more specific instructions, it will help them a lot to understand how the code is actually working. And it's a very interesting tool to use for uh, creating and tinkering and working with as an introduction to CAD, for example. Okay. Here we have another. Sometimes it happens. Even if you just like reset your connection and start again, then it's gonna have it will create much better results. Okay. But uh, I think San is here in the group. So I'm gonna hand over to him so that he can show you a little bit of the more advanced functionalities using ChatGPT 4.
Hey, hello everyone. I hope you can hear me. All right, sounds good. My name's Ishan. I'm from North Carolina, United States. I'm a current senior undergraduate at New York University, Abu Dhabi. And I'm helping Jorge out on this project. So I should be able to share my screen. Okay, hopefully we can see the PowerPoint. So okay, we can see the PowerPoint, right? All right, good. Thank you so much. Um, skip ahead. So I think many of you have noticed that you're getting some errors. Things aren't really working out all the time, which can be frustrating. But I want to go through some slightly more advanced examples of things that we've been able to create. And so utilizing ChatGPT 4, we can input images, which adds another layer of complexity to prompts. I can, take an image of something and ask ChatGPT to try and create a model of it in Blender. So using the same principles, but this time adding an image which was generated by a ChatGPT itself, we got a very, very basic primitive stick man. But a principle that Jorge mentioned was iterating. And so if we take this and ask it to become more complex, please make the model as complex as you can. We see that we get something that is a lot more robotic, even if it doesn't represent exactly what was in the original image. And so these are more of just examples to maybe get everyone thinking about ways that they can utilize this. And I think, like Jorge mentioned, in a classroom setting, it's really useful, especially for engineering prompts and thinking about, how do we communicate with things like ChatGPT in order to utilize it to its best capabilities. And so this is another example. So this took about 3 iterations to try and generate a car. And you can see that the script here was not super specific. It didn't really have any size or color or shape. But 4 wheels and 2 doors on each side of the car. And after about 3 iterations, we got something that resembles a car. And so we found that you can also take traditional sort of CAD drawings and input the image utilizing GPT-4 and have it model the parts for you. So it's interesting to see that ChatGPT can read the diagram and understand the diameter and the dimensions and understand where the hole should go and how deep it should be. And so the first iteration was just the cylinder, but then after one extra prompt of emphasizing that there's a hole through it, we were able to get the final model. And so these are a little bit more advanced examples, but they display the sort of advantage or capabilities of GPT-4 versus 3.5. So in this case, the same prompt was given to both 3.5 and 4. However, the success rates of 4 were much higher. So unless Jorge has anything else to add, I think we can leave the rest of the time for questions and maybe you guys trying out some prompts and seeing what you guys can end up making.
Yeah, I think probably we could try to build something between all of us, and maybe we can follow your screen and your prompting, and then try iterating and see how it starts improving and see.
So I think we can try this castle example, because it is quite interesting. So if you give me a second, I will share my full screen. Okay. Okay. So now we are in ChatGPT. I'm gonna try doing this on GPT 3.5 and we'll see what happens. So if you guys are following along, we'll try and generate a castle. So generate a Python script for Blender 3D to model a castle. Which we could stop here, but I'm going to try and make it a little bit more specific. We can say I want 4 towers, corners of the castle. And I think we can try leaving it with this, and then we can iterate and see if we can improve the outcome. So okay, so we'll copy this code. We'll open up Blender. I'm just going to delete everything that is here. And then if we go into scripting, press new, paste in our code, press play, and it looks like we got an error. Try that one more time. Okay, so we got an error. It says in line 8. So now we can move back to ChatGPT and say, this code gave me error in line 8. Can you please try again? And see if it works. Now, if anyone else is doing this castle example, and wants to include their results, go ahead.
Nice.
So I think we are getting close to being out of time, so I'll give it one more try and then we can move on to questions. I think someone in the chat also said that starting prompts out with trying to convince ChatGPT that it's an expert in Python or in 3D modeling is also very helpful. So again, it threw an error, but I think that's the beauty of doing something like this. You never know what you're going to get. Sometimes it works out, sometimes it doesn't. It's just how AI these days works. So I think unless Jorge has anything else to add.
I think try it out in ChatGPT 4.
Should I try it out in 4?
And we can show them one of the big benefits of 4 is that when you can, because you can input images, then you can have it like in a closed loop. So after it generates the first result, you can easily tell them, look, this is what we're getting, but we wanted to improve in certain way. And that gives it, it takes it to another level.
So we can try it. In this case, I'll try adding an image as well.
I think you read my mind because I was going to ask you to do a castle.
Yeah. I think half of the problem with this is actually trying to think of things that you want to model. But you could use ChatGPT to generate some ideas as well. So I think you guys can already see that it's taking a little bit more time. But I think that means the result might be a little bit higher quality. Meanwhile, if anyone has any questions, feel free to ask. I think Jorge is available to answer.
Yep. Nice. Yeah, so if you see in the chat, you can see, for example, Kathy has already gotten a pretty good result with GPT-3. And actually similar to what you're getting here in 4.
Yeah. So we can see that there's it's getting there, but it's one step closer than we were at 3.5. But I think
yeah, please go ahead. So something we can try before we run out of time is this image, you can input it back into ChatGPT and then tell it to improve.
so. I've attached an image
What if you
of.
just asked it to do the code for a castle instead of giving it a picture? Would it look for any previously uploaded designs of castles?
Yeah, I think because I'm not sure about 3.5, but 4 even has access to like current internet. It can search the internet. So I'm assuming a lot of where it gets its information from is from things that are already out there. I think the usefulness of images comes in because castles all look different, and if I want something more simple, I can post an image of this, or I can post the Disney castle, and I'm sure that would change the output.
But if you
of
see, for example, the what Kathy is getting in the results, she even got some turrets which are inverted. So you could actually iterate and ask it, okay, this is good, but let's invert the turrets and try to connect them to the towers. And incrementally, you can start building and getting better results.
Yeah, I also think someone asked if this will work in sculpting or animation. I know animation can be generated. I haven't tried it myself completely yet, but I think Jorge has, um, and you've gotten it to work.
Yeah, you can even create full animations, normally lighting and movement, but I'll be happy to share some links with examples afterwards for everybody to take a look.
Okay, so we'll try this final iteration one last time and see if it works. Okay. We might have taken a step backwards, but it looks like we got a little bit more detail. Um, we have some walls now. Um, but yeah, I think this is still in its earlier stages. Um, and I know a lot of other 3D programs, things like SolidWorks, um, also have their own scripting languages. I think SolidWorks uses VBA. But it could also be cool to utilize GPT to generate scripts in those languages for other CAD softwares as well.
Yeah, and at the end, this is all simple shapes generated by Blender that you can actually modify, and you can see here in the scene everything that it created. So to answer Christine's question, you can always edit it in the traditional ways using Blender. And if you look at the code, you can actually also try to modify the code. And if you have any Python or programming knowledge, you can see that by making some changes, you can easily modify as Esan is doing now to get closer to the results. And the interesting thing once you do it in a classroom is that some are gonna get the results working, and you can always try to analyze the code and see why it works and what's wrong, so that the others can get there and then incrementally build something. Uh, so when you try this in a classroom, you can see that as they try to experiment, you can get parts of the code for, let's say, the turrets or the bridge or whatever you want to add, and then you can bring them all together in one single computer and generate a final version with much more detail. So we're getting close to the limit of the time. So if you have any questions or you want to share what you're trying in the chat, it will be very nice to see what you're getting.
Okay, also, maybe not now because I don't think I will have time, but when we get back to the main session in the chat, I'll include a link to our presentation. That way you guys can go back and reference it.
Yeah, so this was just a very short, fast example of like the general capabilities of the tool. But as you get into it and start tinkering and working with it, you're gonna see that you can get some very interesting results. And if you have access to ChatGPT 4, you'll have even much more complex capabilities because you can always work in a closed loop by sending back the images and creating a reference to the result you're getting and how you want to improve it.
Can I ask a question?
Yeah, please.
So have you used this with like younger students or like high school or middle schoolers?
Yeah, we've tried it with middle schoolers, and even in the FAB conference in Bhutan, we tried it they were mostly high school students, and it was pretty fun.
No, it seems great. I was just wondering because I was just thinking this is awesome. I really like appreciate this skill. But something that I was thinking was that some of the schools that the students I was working with, like
Mhm.
they completely banned ChatGPT or like they have like different kinds of like ways of using it. But I think this would be like a pretty solid way as like a reason for
So
use, right? Yeah.
exactly, yeah.
As it goes beyond like certain people's knowledge sets.
Yeah. No, and it's a very nice way to see the different conceptions and results that you can get, because once you try it in a classroom and you see 20 different examples, you can see that the definition of a castle can be very different, and some are, or most could be appropriate. So I think we have 5 seconds left. So
Well,
thank
thank
you,
you. Thank
everybody.
you.
Everybody who's here is back.
Hi, everyone. If my volunteers could stop the recordings. Great. So I hope that we learned a lot during that 45 minutes. I dipped into 2. I tried to get to more, but I got pretty invested in that generative AI one. So thanks for that. That will be a dark hole I'll go in pretty soon. I'm looking forward to it. So we really couldn't do this summit. This is really a community-driven summit. Even the organizing committee for the summit are volunteers from all over. In fact, those people who presented this year or are about to present this year will be invited back to be on our organizing committee next year to keep the cycle going, generating new volunteers and also keeping the summit and the ideas that we're presenting here interesting and fresh. So thank you for that. And now is a time I'd like to thank our summit supporter, the FAB Foundation. Now, FAB Foundation has been supporting us all 3 years of the summit, so we're really excited to have them back this year. I've asked Sherry here to share a little bit about the work that FAB Foundation is doing, and if she is online, Sherry, you can grab the mic if you are inclined to do so. Sharing your slide that you shared with me earlier. Do we have Sherry Lassiter? No?
She's there. I don't think her microphone's working.
Does she want to do hand signs? Oh, she.
Okay, now I'm unmuted. Sorry about that. Hi, Liz.
Hi.
everyone. I just wanted to say how wonderful it is to see you all here today. We're so grateful that it's you that's here and pioneering education for our young people of tomorrow, our next generation of innovators and people who are going to run the world for us. So this is the third edition of the Fab Educator Summit, and we are so grateful to Liz for her organizing. Thank you so much, Liz, and also for the entire team. And I don't know if I've captured everyone, and if I haven't, please forgive me. But you all are so incredible to help support this conference, and I think I see that Artur and Lamia and Abigail and Brian and Alethea and Sarah, and there I'm sure are more that I didn't capture, but thank you all so much for making this possible. I see a lot of people here that are friends and that I know, but I also see a lot of new faces, which is really great news. This is growing, and really excited to see your participation. And for those of you who don't know or who haven't checked in on the Fab Foundation in a while, I'm just going to give you a minute sort of update on who we are and what we do. So the Fab Foundation, we were established in 2009, basically to support the growth of digital fabrication everywhere, right? So to democratize access to the tools for technology, innovation, and invention. And we emerged out of MIT's Center for Bits and Atoms, and we kind of divide our work into sort of three different buckets. And one is sort of the .edu bucket, one's the .org bucket, and one's the .com bucket. And so our educational work at the sort of adult level has to do with a sort of a program that we call the Academy, and it's academy.org if you're interested. I'm going to throw these into the chat, these URLs. But the Academy is basically the idea of how to make almost anything, or what we call the Fab Academy, which is a course that Professor Gershenfeld teaches at MIT, and also outside of MIT as the Fab Academy. And you, in the course, in one semester, you learn all the tools and processes of digital fabrication, and then you actually apply them in a project-based environment using a capstone sort of approach. And so the Academy includes this course called the How to Make Almost Anything, but it also is a growing portfolio. And so we have what we're very excited about, and what Liz and Yvonne and also Santi and Xavi from Fab Lab Barcelona are designing for us is a Fab Learning Academy. And so this is very specifically aimed at how we bring educators into digital fabrication and help them use digital fabrication as a catalyst for STEM learning, and so, or for STEAM learning, really. And so the Fab Learning Academy is something that's on the horizon. We did a pilot this past year, and we will be running, I guess you guys will be running a full-fledged version of that in September. Very, very excited about that. This is also where we have Fabric Academy, which is really a course at the intersection of biofabrication, digital fabrication, and design. So for design for fashion and textiles. And so that's another course. And then we have other courses coming. One is a Bio Academy. So how to grow almost anything is what we call it, but that's synthetic biology. And then there are other courses. The Fab All-In course as well. So that's about equity and inclusion across the network, and it's telling the successful stories and helping to design successful programs that will be more equitable and inclusive for your communities. And so that's kind of the Academy, and that's really exciting. But those really aimed at adults, except for, I will call out Charlotte Latin, which is doing an extraordinary job of putting their high school students through the Academy, a very advanced course, and they're doing beautiful work. Tom, you're doing beautiful work there. And so the other piece, though, of the EDU bucket is Scopes DF. And so Scopes is something that actually Liz, I think, helped us to develop it, and Abigail's currently working on it. But this is kind of a platform for educators, whether you're formal or informal, to share lesson plans, to download, upload, remix, to share thoughts. We also are starting to offer contests, and for lessons every month or so, and then also we're also this is where we're doing the Chevron STEM fellowships, the Fab STEM fellowships. So these are $10,000 awards for educators to go and visit other Fab Labs or makerspaces in the world, and to share that knowledge, as well as create new lessons that are more inclusive, with the community. And so that's a really exciting one. I think our deadline is in about 5 days. So if you guys want to participate, want to be considered, go to scopesdf.org and see if you can't apply. And then there's the .org. So in the .org world, we do some humanitarian aid work. We support projects like Fab City, which is about a global project to support cities that, or to support the development of digital fabrication along with public-private partners to make sustainable cities. There's a big effort in the network that we support called the UN, around the UN Sustainable Development Goals. And so, there's an effort for the network to profile each of their labs and maker spaces to which of the SDGs they think they can nicely align and make progress. And then there are many projects like that around the world. Fab.care, which is all about assistive technologies, designing and building assistive technologies. And then there's the .com, and the .com is really more about how do we provide new, how do we use these spaces and this kind of education to provide new economic opportunity. And there's one new thing on the horizon. We'll probably offer it in September, but we're going to pair venture capitalists with students or makers who have great ideas that they're making in the Fab Labs for new businesses. And so it's going to be sort of a mentoring program and a support program for entrepreneurs to be able to create new economic opportunity. And so just one more note, I think down in the bottom middle of this little slide is a very bad but accurate picture of the Fab Lab network. The Fab Lab network's now grown to more than 2,700 labs in 135 countries, and we're still growing, and which is really, really wonderful. And that this year, our annual gathering will be in Mexico. It's Fab 24. And it will be in Puebla, Mexico, and it's all around themed around equity and inclusion. And so I invite you all to visit the Fab Mexico or Fab 24 and join us this summer. It'll be at the end of July to think about together, to meet the rest of the network, to think with like-minded educators, and to think about how we bring equity and inclusion to all of our labs. So thanks very much for being here, and thank you, Liz.
Thanks so much, Sherry. We really appreciate your sponsorship and you being here and sharing some of the work that you're involved in. I know you didn't share it all, but that would be its own summit. So actually, it's its own conference, a 10-day conference in Mexico. So thank you so much for being here. We really do appreciate it. The next thing that I wanted to talk about is a new project that we're rolling out this year from EduFab. It's called the K-12 Fab Open Inventory Project. And really the genesis of this idea, it's still kind of in its idea phase, but I will call on you, the network, to help create it. What we've noticed, what I've noticed and other people have noticed is that there's kind of a lag in updated technological information for teachers and schools that are integrating makerspaces. If somebody types in makerspaces in a Google search, there could be 100 different lists of inventory and recommendations from different labs or from different makers or manufacturers. And what I'm looking for and what other teachers are looking for are teacher specific recommendations. It's almost like Angie's List for tools and technologies in Fab Lab, back when Angie's List was actually a recommendation site. So what I've been doing is over the last year, gathering recommendations from other teachers and kind of compiling them into, well, a Google spreadsheet, to be honest. And this just needs to go further. This is just me pulling stuff together myself. But what I'm going to do is right after this summit, I'm going to launch a call for anyone who wants to enter information and recommendations that they have found that work in their classroom. And specifically, we're looking for teachers that are working with technology and with students. And the questions that we'll ask in this call for help are: how do you use this technology with the students? What are the softwares that this works with? What are some projects that you do with this? And what would you recommend other teachers know before buying this? And in addition to kind of price points and location and that kind of stuff. The other thing that will make this open inventory project kind of big will be that we'll have inputs from all over the world, where you can get different machinery in like China or India than you can get in the States or even Egypt or Finland. So it will be interesting for all of us to have a shared space where we can look up teacher recommendations or recommend things ourselves, and kind of vote things up and down as far as the technology in a makerspace goes, in an educational makerspace goes. So this is a preemptive thank you for participating in the project. I really look forward to seeing this grow over the year, and at the summit next year, we will be able to share the work that we've done, and kind of unveil this new resource for anybody who's looking to use tools and technologies that have been tested by teachers in their classroom. So thanks for that. We are here. We are at the very end of the schedule. Our fast talks, a couple minutes behind, but we can recover. When you registered for the conference, you voted for an unconference discussion topics. Thank you for that input. We have our results from the votes on Eventbrite, and you will see here we have two very clear winners. We've got tools and technology plus recommendations. We've got AI in makerspaces. We've got inclusion and belonging, and we're also going to do the youngest learners. So we're actually going to do 4 unconference discussions. These unconference discussions will run concurrently with the next 3 sessions. So you can self-select, just like any other breakout session, where you're going to be. And speaking of which, I'm trying to get us some time back here, but our first of the short talks is called Session A. We're going to go Session A, B, and C. And our breakout rooms will be Network of Educators in Qatar, Digital Tools in Schools, presented by Ilaria Lamagna from Studio 5 in Qatar. Our second breakout session will be Making Meaning, Middle School Student Self-Awareness and Confidence in a Makerspace. This is presented by Lucy de la Breur from Create, Make, Learn in Vermont, here in the US. Our third breakout room will be Programming and Machine Learning and STEAM Activities with PictoBlocks. Presenting will be Paulo Jorge Nogueira Torcado. I'm sure I was very close to that pronunciation. He's presenting from a school group in Portugal. Also, number 4, we have in our 4th room, we'll have Centering Sustainability with Hands-on Projects. This will be led by Olivia Kotsiva of SYN Fab Lab in Athens, Greece. And our 5th breakout room will be My Machine USA, elementary students design their own dream machines. This will be presented by Adam Maltese from Indiana University here in the US. And then back to our unconference discussion, which will be in the breakout room 6 in all of these sessions. So our first discussion topic is tools and technologies plus recommendations. And that will be an unfacilitated discussion. It also will not be recorded. So so now is the time where we're gonna this is the time where we earn our time back. Everyone knows the drill by now. This is our 3rd self-selection for breakout rooms. So if everyone can, are we ready? Oh, sorry, Lamia, did you open the breakout rooms? Yes, okay. So go ahead and self-select. Thank you so much, everybody.
Thank you.
Thank you.
And Lamia, I'm going to jump into the unconference room. Are you still here?
Yes, I'm here.